Hi, hello guys. Welcome back to my YouTube channel. I'm Sujan Reddy, studying in 6th SEM ISC, Sri Venkateswara College of Engineering. Today we're gonna see about a good topic called as variation and mutation analysis, which is belong to a software testing and software testing subject. Okay, let us see what are all the contents that has been discussed about today. Okay. Uh, in going before going into the context, let us see what is the introduction to the mutation analysis. Mutation analyzing is a software testing technique used to evaluate the quality of the test cases. It involves a small changes in a source code known as a mutant, and then running the test cases against these mutants to determine if they can be detected or not. As previously told in my one of my video, we cannot build or run a software, a whole software system on a one single test or a one single execution. Okay, we will take unit by unit and unit by unit, and we will later on we will execute them. We will verify whether it's working properly and it is giving a quality output, and we will analyze all those test cases. Okay, in this analyzing the test cases, the mutation analyzing is a best technique or a good technique that is used to evaluate the quality of the test case. Okay, it involves creating a small changes in a source code. Okay, we'll change some, so we'll make some changes in the small source code. Okay, when we need to sort some binary. Okay, let us think about a binary search where things should be input should be given in a ascending order, but it will source code will be changed as a give into the ascending descending order and get the output. Okay, the in that case it should give us the wrong output. If it's not given a wrong output, then it will be the code that has been the unit that is will be executing the wrong fault. So we will check here for that cases. Okay, and next we see variation and mutation analysis. The mutation analysis process described in the preceding section, which kills mutant based on the outputs produced by execution of the test case. As I told, it is a preceding section which kills the mutant based on the output based produced by execution of the test case. Is known as a Sang mutation. It can generate a number of mutant quadratic in the size number of program. Each mutant must be compiled and executed with each test case, and it is killed. The time and the space required for compiling all mutant for executing all test cases for each mutant be impractical. Okay, it's saying that when we go and execute and change the source code and and we will test the text the test some specific parts. The time and space required for compiling all those mutant is it's not an impractical thing. Okay, the compactual effort required for the mutation analysis can be decreasing the number of mutant generated and the number of test cases to be executed. Weak mutant analysis decrease the number of test cases to execute by killing mutants. They produce an intermediate state rather than waiting for a difference in the final result or observation program. It's saying that the compactual effort required for analyzing can be decreased the number of mutant generation and the test cases can be executed. The compactual effort required for mutation is decrease the number of mutant generated for generating the test case. Okay, with the weak mutant, a single program can be seeded with any fault. A meta mutant. Okay, you know what is the meaning of meta? Meta is nothing but a definition or a data that the data that will be containing the definition of other data. Okay, the definition that will be containing another definition is called as a metadata. In the same case, meta mutant, the mutant that will be holding some another mutant is called as a meta mutant. Okay, program is divided into semi-segment containing original and a mutant source code with a mechanism to select which segment to execute. Two copies of a meta mutants are executed in a diagram, one with the only original program code selected and their other with a set of live mutants are selected. Okay, and here the execution is a okay, the execution is passed after each segment to compare the program state of a two versions. If the state equivalent execution resume with the next segment of the original and mutate code. If the state differ, the mutant is marked as a deal, and execution of original and mutate code is restarted with a section new selection of mutant. A weak muting test does not decrease the number of program mutant that must be considered. Okay, if one is designing the test case to kill particular mutant, then it may be important to leave a complete set of mutant generated by a test of mutant operation. If, on the other hand, the global is a statistical estimate of the extent to which a test suite distinguish program with the seeded faults from the original program, then only a much small statistical sample of mint is required. Aside from this limitation to assessment, rather than the creation of the least suite, then the main mutation of the statistical mutation analysis is that partial coverage meaningfully only to extent that the generate mutant or a valid statistical model of occurrence frequency of actual faults. The avoid the avoid reliance on this impossible assumption. The largest coverage should be 100% of sample. Statistical sampling may keep the sample small enough to permit. It's saying that how important is the distinguish between the program, original program, and the mutant, a small statistical program, and what are the limitations that are given to this mutant program and all. Okay, I here in the challenges in mutation analysis, or one of the challenges in mutation analysis is the large number of mutants that can be generated, which can make it impractical to text of them. Another challenge is decreasing which mutants are equivalent, meaning that they do not change the behavior of the program and therefore don't need to test it. Okay, one of the challenges in mutant analysis is the large number of mutants that can be generated, which can make impractical impractical to text. Okay, I said that in previously, the generating the mutant and running and testing those mutants are impractical of time and space. Okay, it may take more time, or it may take some more space, which that cause a redundancy of an memory space, that may cause some another goes to the cost and another other problem. So it's an one challenge. Another challenge is determining which are equivalent, meaning that they do not change the behavior of the program, therefore it don't need to be tested. Okay, see, one time one thing, if one thing is going wrong, and we not need to check for all the other thing that is being going wrong or not. Okay, if one similar thing is going wrong, then no need of checking for all the four remaining things that should be gone wrong. Okay, so we can overcome also this challenge also. And finally, the conclusion part. Let us see what is the conclusion part. Okay. Mutation analysis and its variations are important tools for evaluating the quality of software testing and ensuring the celebrity of software application by understanding the challenges of the technique software. Developers and testers improve their process and deliver better product to users. Okay, it's saying that in mutation analysis, after those seeing the challenges, it's also a very good analysis that visualize are important tools for evaluating the. I said in before only, we need to have some quality goals and quality outputs that should be given out. Okay, simply building a software and doing something. Okay, we got some related output or some okay, this I got out of 10, I got 5 outputs. It's not like designing software, like it should be like 100 or 0, fail or pass, no remaining things first class, second class, and so it's a very good thing. Analyzing a mutation is a very important, a good thing in the any kind of software testing. Okay, thank you for watching. Please like, share, and subscribe my channel, and it's an assignment given by our college. Thank you so much.